So this is the project where I got to choose any element from the periodic table. I chose uranium. So this is a picture of a uranium particle. It has 92 protons and 146 neutrons in the nucleus and 92 electrons orbiting. It has 7 layers of electrons, which means that there are 7 orbiting layers, and each layer has its own number. So 2, 8, 18, 32, 21, 9, and 2, which means that layer 1 has 2, layer 2 has 8 electrons, and then so on. So, there are many parts of a particle. There are protons, neutrons, and electrons, which you've heard before. But what are they? A proton is a particle with a positive charge, a neutron is a particle with a negative charge, and an electron is a particle with a neutral or no charge. Protons are found in the nucleus of an atom along with the neutrons. Electrons are found orbiting the nucleus of an atom. You've probably heard of an atomic number and a mass number. An atomic number is a number that is equal to the amount of protons in an atom. The mass number refers to the amount of electrons combined with the amount of neutrons in an atom. The amount of protons should be equal to the amount of electrons in an atom. If an atom has a different number in the nucleus than the number of protons, then it is an isotope. Sometimes a group of bonded atoms lose or gain electrons, causing a positive or negative charge. This is called an ion. A positively charged ion is a cation, and a negatively charged ion is an anion. This is what uranium looks like on the periodic table. So this is a picture of uranium. The atomic symbol is a capital U. The atomic number up here is 92, which is the amount of protons, and neutrons and electrons together equals 238, which is the mass number. It is also an actinide, making it very volatile and radioactive. Earlier, I said uranium is an actinide, which means that it is radioactive. An actinide is a metal, making it solid at room temperature with a melting point of 1,132 degrees Celsius. That is about 3,300 degrees Fahrenheit. Uranium is highly radioactive, and because of this, it goes through radioactive decay as it ages and turns into thorium. Uranium oxide is a compound including uranium and oxygen atoms. Uranium oxide is often used as nuclear fuel in reactors. Uranium hexafluoride is another compound used for nuclear reactors. It is a man-made chemical created by combining uranium oxide and hydrogen fluoride, another compound. Uranium is difficult to see considering it is an ore, but you can see nuclear reactors and weapons on TV. No one is really allowed to see pure uranium or its compounds unless you are some sort of scientist in the chemistry field, mostly because of how volatile and dangerous it is, and safety precautions need to be taken. Uranium is commonly associated with this symbol. This is a sign that means radioactive. Since uranium is the most well-known and commonly used radioactive material, they are often associated with each other. Uranium is very important in a few ways. It is used in many reactors to power electricity. It is also used for some military vehicles, and most importantly, a lot of bombs and weapons. So this is a chart about keeping nuclear energy. Pros and cons of keeping nuclear energy is efficient energy, and it lasts for many decades, up to 80 years. But the cons is that we use them for military weapons, disasters occur, dangerous, since it is dangerous and volatile, many lives get lost. It has a lot of environmental impacts, such as leaks and pollution, and it also causes arms races. So what if uranium and other radioactive elements never existed? Here is another chart without Here is another chart. Pros and cons. The pros is that we'd have less weapons, which might mean less war. There won't be an arms race, no disasters, and less pollution. Less The cons is that there will be less efficient energy, a future energy supply would be gone, and there would be more greenhouse gases since we would use fossil fuels. Without nuclear energy, disasters like Chernobyl and Fukushima wouldn't have happened, A large reason for the Cold War and the arms race was the introduction of nuclear weapons. Although our energy usage wouldn't be as nearly as efficient as it is today without nuclear energy, I chose to study uranium because it is an interesting element that is commonly used and I did not know that much about it. Thank you.